This is the Cycle World podcast. Welcome back. I'm Mark Hoyer. I'm the editor-in-chief, and I'm with Kevin Cameron, our technical editor. Today's topic is the Honda CB754, introduced in 1969. A motorcycle that invented the superbike, brought together many technologies that had not been combined into one vehicle in motorcycling, made a huge impression and set us on the course that we have enjoyed pretty much to this day.
Yes.
From a performance standpoint, I was going back through the Cycle World archives, reading the road test. There was a lot of good stuff in the original road test. The motorcycle made a huge impression. In 2010, we asked the late Massimo Tamburini of Ducati 916 fame and all those gorgeous modern era MV Agustas what the most important motorcycle in his life was, and he said it was the 1969 Honda CB750. He said, "I still remember the incredibly intense emotions that the original Honda 754 generated down in my guts when she was unveiled at the Milan show in 1969. She was like a vision, a dream come true, the bike I never thought a motorcycle company would dare to put into production and make accessible to the general public." It goes on. It's fabulous. And that's Massimo Tamburini, designer of the most evocative things, part of Bimota, he raced CB750 and, he did find a way to improve it. I filled him a frame, but I think what struck me after reading your research and doing my research was that the motorcycle represented confidence in Honda, confidence to combine all of this into a motorcycle that they had to know would sell, or maybe they didn't. The first ones were sand cast, and I wonder if that was maybe a lack of confidence before committing to die casting, because die casting is very expensive, sand casting is less so. But in any case, it did to me represent a lot of confidence, and it had a lot of technological improvements in motorcycling combined into one product.
Well, in 1967, they sent Yoshio Harada, who had been with the company since 1953, on a tour of the U.S., ostensibly to urge dealers to sell CB450 harder. Now, CB450 was the flagship motorcycle at the time from Honda. 40-something horsepower at 9,000 and 500 pounds of weight. And it was in amongst them in terms of quarter-mile time, but it was not definitive. And, of course, this is mid to late 60s, so the faster Nortons didn't exist yet. We're talking about Bonnevilles and BSAs. And, of course, the Sportster. So there was the early CB450 at roughly 15 seconds ET. The others were high 14s. The CB450 improved, but again, it was not a definitive statement from Honda. Match this.
Well, anytime you have to send someone out to convince a dealer to sell something harder, you better talk about the actual product. What is it bringing?
What Mr. Harada noticed was what people were riding and their attitude toward what they were riding. And of course, at this time, all motorcycles were twins. And specific horsepower was, in modern terms, very low. All these engines were air-cooled, so you had to design, set the compression ratio, set the mixture rich for crossing Death Valley in midsummer. No detonation, please. So keep those warranty claims back. So I would argue that it was the American side which pushed so hard. You can do this. you have created, you own the words Honda 4 wins again, which have been instilled into the minds not only of motorcycle riders, but of lots of people who never thought of a motorcycle worldwide. So what were they doing with that? They were making twins. Honda 4 wins again. They won for the first time in 1961 and went on winning with four-cylinder 350s right into 1966. So they had four cylinders down, technically speaking. But if you look at CB750, what you find is that it's built out of the same Lego blocks that the twins were built out of. Single overhead camshaft, rocker arms with radius pads, and with the clearance adjusters on the end where they rattle up and down. And if you don't get it insanely tight, it comes loose and your valve system beats itself to pieces. So do get it tight. And center drive by a single row lightweight chain to the single overhead camshaft, and two strands of a much heavier chain from the center of the crankshaft to the gearbox. And all of these elements were present in the twins, except for the primary drive from the center. And all Honda had to do was say yes to Bob Hansen, who was the American Honda service training director, who had run his own G50 matchless racing team, who knew all these people like Dick Mann, who was deep in the American motorcycle tradition. He knew in his heart of hearts that a four-cylinder Honda would sell. And Honda had got their construction of motorcycles down to the point that they could say motorcycles cost X per pound to build. And it wasn't going to make a lot of difference to them how many cylinders it had, how many rocker arms, and so on. So I would argue that the Japanese just weren't yet tightly clued in onto how important quarter mile time and 0 to 60 time, top speed, those three numbers, were to American buyers. So when they put those elements together, the result had about the same specific horsepower, which is, in this case, horsepower per liter, around 90 horsepower per liter. CB77, the hump-tanked early 60s twin, 305, many of us rode. And the CB350, which was a later arrival, 68, but still before CB750. And Kawasaki Z1, arriving in 1973, had the same specific horsepower, 90 horsepower per liter. So everyone had agreed we're going to have compression ratio around 9-to-1. We're going to have around 220 degrees of valve duration. We're going to lift the valve 25% of head diameter. It was a formula. It was a Lego block. And Honda put this thing together. They tooled it for production. And it may be that they made the early models using a small-scale production method rather than the large-scale, low price per part die-cast method. But when it hit the shows and the showrooms, it was a sensation. 4 cylinders, 4 separate mufflers. It was impossible for a private citizen to own such a marvelous thing. Oh, You think so? Bring 1495 and see how quick you roll out on a new one. So I really feel that the Japanese were behind in their appreciation of what the American market was really like. The British thought they knew. They had enlarged 500 twins, the original Edward Turner engine of the late 30s, into 650s. Royal Enfield made a 700, 750, 835, vibrating harder and harder with every enlargement. Whereas if you reconfigure as a four-cylinder with a flat crankshaft that has 180 degrees between the outer and the inner crank pins, primary shaking force is balanced pretty much by the fact that half of the pistons are going one way and the other half are going the other way. It does have secondary vibration, but at this time, people were accustomed to primary shaking force of an enormous magnitude.
Yeah.
And of course,
I
dealers,
let one of my colleagues ride my 850 Commando, and he was not a vintage motorcycle person. It had those tennis ball shaped grips that were already, the ball shaped grips. I forget what the brand was on them, but had those tennis ball shaped grips. And that was a smooth motorcycle. That was a 74 Commando with isoelastic vibration control, which was pretty darn good. And he rode it up Coast Highway 2 miles. We traded on the way home from work. And he got off and was shaking his head and said, "How do you ride that thing?" Yeah, we were used to something else at the time, weren't we?
Yep. So why did Honda give CB750 plain bearings? Well, they knew the labor cost to assemble a pressed together roller crankshaft for a twin. Did they want to pay twice? When you make a plain bearing engine, which of course all automobiles except for Porsches were at that time, the crankshaft comes from the forge. It's descaled. It goes to rough machining. It finally goes to have its journals ground to dimension. Nobody touches it until it's going into the crankcase. So that's one point. There is no labor lost in pressing the thing together from a multitude of pieces and then trying to knock it straight using a hammer and a dial gauge.
Well, to quote the 1969 Cycle World test, there is much argument in favor of the plain bearing.
Well, the other argument is plain bearings have a great deal of damping, which rolling element bearings do not have. And they are extremely stiff radially. Trying to push the bearing off center requires an enormous force. So, and it was in 1953 that Commendatore Ferrari ordered two otherwise identical V12s built, one with English-made 3-layer plain bearings. He was an enthusiastic customer for these bearings from
Vanderbilt?
Vanderbilt, yeah, Tony Vanderbilt, and who had licensed it from the inventors in Indianapolis. So the other engine was built with all rollers, and they ran them in direct comparison. And the decision was plain bearings from now on. No more of this nonsense. In the USA, a few years later, it was Junior Johnson building two otherwise identical V8s and testing them back to back. Once more, plain bearings were the choice. The last time rolling bearings ran in Formula One was sometime in the 60s when Porsche was still at it.
Yeah, Honda's
So,
V12 was running plain bearings, their Grand Prix car back
yeah.
in the 60s. Yep.
So, uh, Mr. Honda was known to have an affection for rolling element bearings, and all of their Grand Prix engines of the 1960s, including the six-cylinder 250 and the 297.6, were assembled from a multitude of little pieces with one-piece rods and all rolling element bearings. They were the most beautiful things. They made your heart ache in sympathy with people who could align such a thing. Oh, I've nearly got it. That last tap made it all wonky. I guess it's going to take another hour. I'll make coffee.
I'll tell you
And
what, truing a twin crankshaft like an RD or something can make you insane.
it can.
It takes a special person. I won't name names, Gary Braun, to get it to beat a crank to absolute zeros. Everything's got to be just right, and then you've got to, boy. Anyway, I can't imagine a six-cylinder crankshaft, especially with all those little delicate pieces. And
every crank pin a different size.
all right, because they
The
tapered
outer
out.
ones were little as they got inside and had to transmit more torque and resist the vibration of the outermost pieces. They got bigger. So it was just a tour de force of machine shop
I just
madness, of
I'm a big
embracing perfection.
Yeah, I'm a big fan of complicated ways to do simple things. I really am. But plain bearings, man, let's do it. Let's
Yeah.
forge ahead, as it were.
So Honda chose a plain bearing crankshaft, and it's a one-piece forging. And instead of it's typical for a rolling element bearing crankshaft to be good for about 10 hours of operation at racing speed. Now, Kawasaki C1, which came out in 73, was an anomaly because it had plain bearing camshafts with little inserts in there, the cutest little things, and an all roller crankshaft. And of course, people didn't change those crankshafts every 10 hours because they weren't turning over 10,250 RPM, which was the number that Rob Muzzy said above. When you get to 11,000, things go south in a hurry. So, and of course, people like myself who've had pressed together crankshafts apart in front of them in numbers know that when you start revving those things up, you take them apart and there's red discoloration in the press fit. That is iron oxide, which is generated by minute relative movements inside the joint, which is pressed in there with tons of force. It can't move ever. And then if
Fretting.
people also would like to go and make little welds there, that'll hold it. I've seen many of those welds come in on a crankshaft repair order, and everyone's got a crack right down the middle of it. So Honda solved a lot of problems with this crankshaft choice. It was a wise piece of work. At the time, there were people, and I may have been one of them, who yearned inexpressibly for infinite continuation of roller bearing crankshafts. But they don't make sense anymore beyond a certain point. I think the Honda 6 and the Honda 5 were the high watermark of that technology. Just wonderful stuff if it doesn't have to run all week. And when they warmed those sixes up, they warmed them up in a way that made you think they got a lot of crankshafts in the truck. So, why 2 valves per cylinder? Well, all their production bikes had 2 valves per cylinder at this point. And their engineers had probably become familiar in university with the discovery of the aviation industry that the more holes you put in the head of an air-cooled engine, the more cracking and deformation it will suffer. So There were some 4-valve aircraft engines built, but they reverted to 2 valves, and all those giant American radials, the R3350 on the B-29, the 1820s that powered the B-17s, all 2 valves per cylinder. Then there's another point, which I didn't know before I was sent to study this by the operational plan. But when Harada designed the CB450, he gave it the large valve-included angle and deep hemispherical combustion chamber that the earliest Honda road racers had, and I think it's around 78 degrees. And when he designed CB750, he gave it the much lesser valve-included angle of 56 degrees, resulting in a shallower chamber that did not need a pop-up piston dome to achieve a high enough compression ratio to make solid torque. That was the valve-included angle that Shoichiro Irimajiri had given his CR115 and CR149, and also his remake of the Honda 6. He had given them new fast burn combustion chambers as a result of his constant work with those high RPM engines.
Yeah, pistons were nearly flat on the CB750. They had a very tiny crown.
Yeah.
And there was
the
a lot of work
compression ratio was 9-1, and which is not a lot by modern standards.
And an under square bore,
Yes.
bore and stroke rate. Yeah, 60.
Now, all of their twins were over square. They had larger bores and shorter strokes. And so you would say to yourself, what is this pre-war bore stroke ratio doing on this 1969 product? Well, if for the sake of simplicity and moderate manufacturing costs, you're going to put your 3-phase excited field alternator on one end of the crankshaft, and you're going to put 2 rows of chain, primary chain, plus 1 row of cam drive chain between the 2 pairs of cylinders, then maybe it makes sense to make a smaller bore and to allow airspace between the cylinders so that cooling air could travel between the cylinders and do a more complete job of cooling. Because what cools air-cooled engines is air passing through the fin space, and it doesn't like to. It would rather blow around it.
Well, that's
so
one
those
reason.
Holes were very important.
Yeah, it's one reason the fin pitch on motorcycles isn't fine like it is on aircraft, because it isn't ducted and forced to go between the fins. Because you see those elegant and multitudinous fins on big radial aircrafts, and you're just like, that's beautiful. Why? And they were cut. Some of those fins were actually machined on aircraft engines to make them so fine. But you don't do that on a motorcycle engine because you just have to. They're not ducted typically. You just have to rely on, riding down the road and having it get in there. So that's why the pitch is wider.
Typical fin pitch for motorcycle engines is 1/4 inch. And if there's mud involved, it has to be bigger. So, whereas for the B-29, whose fin pitch was like 220 thousandths, which is a little bit less, they needed 12 inches of water pressure to push enough air through their fin space. Those engines internally were ducted solid, so the only way through the engine was through the fin space. They needed 12 inches of water pressure in the front, pushing air through that space so that they could run climb power. Otherwise, they would have to just cruise along at low altitude and low throttle until they burned up enough gas to climb. So when you start to make large amounts of power continuously from an air-cooled engine, then you have to start getting really clever about the cooling. Whereas motorcycles, you can't go far at maximum speed without either encountering a coroner or a policeman. So that makes cooling a lot less formal. But those holes between the cylinders were very important on an air-cooled. You can't just have air blowing on the thing like it's a suitcase left in the sun. Its air's got to go through. So those holes were important, and having small enough pistons to afford those holes was also important. So in the end, it didn't matter much because this wasn't an engine that was struggling for the last horsepower. It was a 90 horsepower per liter moderate engine. And in the Cycle World test, it said that it was in a very mild state of tune.
Yeah,
which
not
is
a lot
why
of
it was easy to ride.
Yeah, not a lot of overlap, and but it performed better. You know, it was an inline-four. It revved higher. It was smooth. It gave this sensation to riders that they'd never experienced before. I want to read about Larry Lilly. So we did a 25th anniversary story because we haven't talked about the Triumph, the British coming up with their sort of half-hearted multis.
Oh dear, it's such
too
a
late, but
depressing story.
it is because they'd really owned kind of the sporting market, the lightweight, handy, Triumph 650s they're charming, they're wonderful to ride, but they
And they were
vibrated a lot.
light and
Yeah,
handled well. Yeah.
yeah, and they sold in big numbers because they were good motorcycles. They did leak a little bit, but this is Larry Lilly, owner of Larry Lilly Honda, Lancaster, California, from Cycle World at the 25th anniversary. CB750s, I sold the hell out of them. At the time the CB750 came out, the 750 Triumph Trident also was just out, and there was no comparison between the two. The Honda was much more refined. Without a doubt, it was a better product. I sold probably 20 CB750s to every Triumph triple I sold. The very few diehard riders who bought the Triumph 750s, every single one of them traded it back in on a Honda. I was a diehard Triumph fan myself, and I hated to see it happen, but the British motorcycle industry had its head in the sand way too long.
Yeah. See, people who were anticipating the three-cylinder, which had been rumored for the better part of 10 years, what the Triumph lovers wanted to embrace, the love of their life, was going to be some kind of super Bonneville. It was going to be a definitive knockout blow for those built-up Sportsters. And when it arrived, it had styling that looked as though it hadn't been influenced by anything. And people looked at it and they said, what are those little pea shooter things sticking out of the mufflers? Well, that's it's a mumble. Oh, well, good.
It's
Mumble.
the future.
Yeah. And people called them Buck Rogers mufflers. We had them hanging in a back room in the dealership. And we also had those gas tanks because people said, can you put a Bonneville tank on this? Yeah. Okay, I want one. How much is it? I'll give you the money right now. Because they wanted that ugliness to be gone. Go out of my face. And years before, it had been proposed to Triumph management, which, by the way, was constantly changing. So you weren't dealing with people who had been in the motorcycle industry all their lives and were industry veterans. They were some kind of holding company lieutenants and other strange beings. So Bert Hopwood, who worked for everybody, he designed Norton's original post-war twin cylinder head, which still is an outstanding piece of work. He tried to sell Triumph on, let's build a 250 single, a 500 twin, a 750 triple, and a 1000cc four. And this is before Mr. Harada was sent to eat strange American hamburgers on his 1967 tour. This was before it could have been done. It wasn't done. Oh, well, why would we want to do that? And it'll cost money. Oh, dear. And my lunch date is here, so can we talk about this next month? And anyone who's worked in business has heard these mumbles. And they mumbled their way to giving away the market. And in fact, in some cases, when people would say, I don't like the way this model looks, they would be told, it's not your job to design motorcycles. We do that. Your job is to like them and buy them. Oh, I didn't understand that. I thought maybe the buyer had certain expectations here. So what the Triumph Trident was 2 cylinders of a 500 with another cylinder added on, and it was done in a sort of strange way so that the clutch was buried in amongst a lot of aluminum, and it didn't make a lot of power. It could, because the Dick Mann won the Daytona 200 on one in 1971. But the choices that were made were like committee choices. Well, I want to do it this way. Well, I want to do it this way. Well, can't you fellows compromise? We don't. Compromise pleases no one. Okay, that's the best we can do. Here's your Trident. And I'm sorry about it, because I got started with my enthusiasm for motorbikes with British stuff. And I only gradually was able, the rational side of me persuading the emotional side, no, look here. Look how they're doing it. This engine opens like a clam. There's the crankshaft, the 2 gearbox shafts, and the kickstart shaft. Just lay them in there, line up the bearing alignment rings and pins, put it together. It's done. Not a lot of pushing and shoving. Oh, you need this extractor, special tool number such and such. And people were accustomed to it. My mentor and first motorcycle dealer claimed he had the second Triumph dealership in North America. Clarence McConney of Everett, Massachusetts, had all these motorcycles he had repair orders. There must have been 50 motorcycles in this one room, and he was grinding through it ever so slowly. And when he was invited to go for a Saturday ride with his friends, they would ride up on their late model Japanese bikes, and Mac would be tightening bolts, checking fluid levels, checking tire inflation, checking, as if he were going on a test flight in a prototype aircraft. Wait a minute. This industry is doing way better than that. You don't have to do all that silly nonsense. Just get on the bike, turn the key, and go. Well, it didn't take long for that kind of motorcycle enthusiasm to just dry up and blow away, because if you're offered the difference between having a half hour more riding because your bike doesn't need all that attention and fussing around and then having to go and put on clean clothes and wash your hands before you can ride, forget it.
I'd say for most people, yes, I agree. But, it sounds like Mac's relationship was forged on all of that. That's part of his.
It was.
And for so many people, and even for me, I mean, I have the great fortune of riding a lot of modern motorcycles, and I even own some that could be mistaken for modern, like a 95 Ducati 900 SS or my wife's 2011 XR 1200X. you still, dare I say, Velocette, lots of fiddly shims. You got to shim the magneto and just all the carefully put it together, and not everything is machined flat, and you got to put sealant on everything when you're building it, and then go through a very specific starting procedure on the Velo. As a 500 single, you better put that piston in just the right spot for it to start. Just like with Yamaha 500s that had the little window, the XT and the SR 500 had a window on the camshaft with a silver dot on it, and you were to kick it up against compression and then move the Kickstarter until you saw the silver dot. And then you could kickstart the bike and hopefully not have your femur end up in your armpit from kickback. And like, that's part, it is part of the relationship for some people, but
I embraced it for a time. I had a 500 HAS single, and you had to pull the compression release, remove the oil cap, and push it through until you saw a little oil pule out of the return line.
It's so true.
There is oil, and the pump is working, and the hoses haven't slipped off.
It's what you do on a Velo. On a Velo. My oil feed has a clear hose crimped onto it, so that if it's been sitting a while, you kick it through until you see oil. It takes 50 kicks, just so you know, 50 kicks to get oil to come up and start to get into the cylinder head. But once you see the oil there, you're like, okay, I can start now.
Yes.
Like 50 kicks.
And then, so this thing has this procedure where you position the crankshaft so that you have a maximum time in which to deliver kinetic energy from your poor leg to the crankshaft rotation so that it can make it through compression one time.
Near enough to compression, far enough away to get the momentum up, but near enough to make it through.
Yes.
None of this random just throwing your leg at it.
All you CB750 owners of yesteryear, did you have to press down the float depressor on the carburetor until the top of the gearbox was clean? No. The carburetor retained fuel from one use to the next.
Yep. And you had a choke lever, and you could adjust the individual levers between all of them racked together so that the chokes even were synchronized.
So it was a complete change of culture. The Japanese brought us turnkey motorcycling with reliability that many people at the time called boring, because being at roadside and having $9.74 and no cell phone, it's sort of exciting. or is it just a crashing, dreadful bore? Anyway,
well, just the desperation that you saw from British motorcycle manufacturers. They were producing ads at the time that showed, big burly guys, very stylish, with their Triumphs. And it was like, it was so 1971. It was like, manly this, and like, you want a motorcycle that you don't need that. You need this man's bike, and it's going to, kick vibration. And it was like trying to make a feature out of its retrograde, behind the timesness.
Yep. Well, it was with a tremendous sense of achievement that the engine might go pack and then idle. And you would think, I did it. It's running. Or you might kick and kick, remembering to calm down between each orgasmic effort. So, yes, it was a change of culture, because to be an insider in motorcycling in 1960 was to embrace all of this and to understand how to operate a screwdriver without having to see a training video. No shit. This is something that happens these days because people don't grow up in a shop. They grow up in a child safety seat with a workbook. And they have to wear helmets if they're doing anything that is somewhat risky. So
Not every kid, man.
not every, no, not every.
My son had a welding helmet when he was 4.
Good one.
I mean,
Well,
it's not auto darkening or anything. You know, I got the auto darkening helmet, but he had the inspector's helmet. But he's welded.
yep. So people had to choose between those cultures, and really, it was like it says in the book on the culture of scientific revolutions, in which it says people don't gradually change their mind and adopt the new interpretation of the data. They die and stop talking. And the people who are left, who are part of the new way of interpreting the data, are still talking. And that's why our collective opinion appears to change. But it's not change, it is replacement.
Well, I want to say the generational marketing that Honda achieved did do something, right? We had You Meet the Nicest People, and
Tremendous.
you had
Oh,
all those lightweight, affordable, approachable people, and then images and advertising showing tennis players and sweaters and,
it was
cheerful people.
lighthearted.
Yeah,
Yes.
no face tattoos, no neck tattoos, just
And no
charming.
femur up in your
Right.
armpit.
And so it began, you had those affordable, in the beginning, hardware store motorcycles. Meanwhile, at the Isle of Man, Honda's showing up with world-beating products, which you
Yep.
cannot buy. And they had this foundation of customer in the United States riding, these things that don't puke oil, they just run, they're high RPM. And you brought together this GP technology and this customer base that was gradually taken up the chain, and they just collided in 1969, and away we went. And
Yeah.
it's really at that moment, I feel like that was the moment when, like, the arms race began, where technology drove next year's sales more than ever. I mean,
Absolutely.
I think, go ahead.
Because CB750 was the doorkeeper. It unleashed the flood. When CB750 appeared, everyone realized what the nature of the American market was. Next, you had Kawasaki's H1, which was the night rider's favorite ride for a very short time. Then you had the 3-cylinders 750s from Kawasaki and Suzuki in 1972, and in 73, the Z1, and in 76, the Suzuki GS series. So once the gates were open, it all poured through. And 90 horsepower per liter, forget that nonsense. 2 valves per cylinder? Are you kidding me? It was an intense technology race, and motorcycle racing was an important part of it. But these were very civilized motorcycles. The thing that I was very impressed with was talking to Cycle World people who'd been there at the basic 200 mile per hour test on their secret desert road, and that making the return run and stopping, the engine just sat there and idled, dum, 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 dum. That's civilization. Tremendous top speed, fantastic acceleration, but it's not a helicopter that requires hundreds of hours of maintenance. So that's an accomplishment. And of course, it was accomplished not because people at the time in the 1960s said, well, it's cheap labor in Asia and that's the cause of it all. But in England, they're civilized. They build they're free men building great motorcycles. Well, okay. But in fact, what Edward Turner found when he made his 1960 trip to Japan, he came back and wrote a report basically warning them. These guys are coming for you, and they're armed with production systems that offer low cost. No more handwork, no 8-sided wireframe spectacles and peering at micrometers and scraping bearings in. They just assembled these things from parts whose quality was assured by systematic analysis. So
the British love of shims. I mean, honestly,
yeah. Well, it was the way a foreman fitter would do things. And I tried to do that.
Yeah.
I tried to do that with my first Kayaba fork that had Teflon bushings. This was 1976, and the thing was, I always try forks when they're empty first, because then you can feel and all sorts of stuff that oil would normally just squash out seemed terribly loose. So I put shim stock behind the Teflon faced bearings. The rider went out for first practice. He said, the fork's sticking down. Oh, it needs that clearance.
When inverted forks came out, you had to run more. They had a lot more clearance, the inverted fork, and like, this is all wrong,
0.005 of an inch in there.
And I talked to guys who were building suspension at the time. They're like, "Oh no, this can't be right."
Yeah,
and they did the same thing. And like, well, that doesn't work at all. So back to the clearance,
and away with the shims.
Yeah,
because a shim, any time that you have to stop production and make a measurement, oh, well, hey, we don't have any of those shims. Oh, here comes the kid with a box of them now. That doesn't cut it anymore. Production line has to operate like a circulatory system. It serves all parts of the body, and it collects nutrients for distribution. Everything comes to the production line that just churns out fresh equipment. Lovely. But of course, particularly older persons such as myself may pine for the engine builder to whom they took their Harley engine every so many years. I knew one fellow who had his engine built every year. And these were people who in many cases would talk to you. They were full of lore. There was all this. You felt you were getting to know your engine well from this. You weren't just a person who said, I want some toast. Where's the toaster? We don't have a toaster.
Tribal knowledge is so seductive. Tribal knowledge is really seductive.
It is. Yes, because it becomes identity.
It's part of the charm of my 900 SS, because it has desmodromic valves, and you got to shim those things. And I don't do that because I don't want a tackle box full of shims for one motorcycle.
Yep.
And then you can read up on most of that, but there's all these little things about the ridges that wear. And if you just change an old shim for a new shim, it will take up the clearance and you'll be good till the next valve checking. And so that's where I relied on my friend Ed. And I take everything off the bike, because that's what you do on a 900 SS. Is the manual just says take off everything and then also take off the shock.
Yeah.
To get it, because the rear valve cover. And then I just let him do the deed, and he brings his tackle box of shims and years of experience, and it's the same. It's just that charming bit of lore that you do like.
And of course, if you do a lot of work yourself on particularly older machines, as Mark does with his beloved Velocettes and other stuff, you have to learn this stuff, or you're going to make a mistake. And of course, that's how we learn. You don't learn from doing things perfectly.
And you learn from
consequences.
You learn from other people's mistakes too. So
yes.
I have an XS650 that I've been working on, which has been really fun because I've never had one. And you get into it, and I was like, well, the clutch was slipping, and it's a 36,000 mile bike, and it hasn't seen the greatest care in the world. And I took the clutch cover off, and got in there, and it has 6 screws holding the clutch on. Number, whatever they are, number 3, JIS. They're the big JIS. They have screws, it looks like a Phillips, but it's not, folks. JIS, Japanese Industrial Standard.
Yep.
And I went and got my impact driver, because I tried to undo them, with the straight up screwdriver. It wouldn't come out. Got my big honking impact driver and went tick, and would not move. Tick, not moving. I mean, tight as could be, in which a spring, those are supposed to be 7 foot-pounds, usually 7 to 9, something like that. And so you learn from someone else's mistakes. Those things were, I don't know what torque they had, but they were nearly impossible to get off. And one of the bosses in the clutch was cracked where the screw would go in. So somebody was like, this is not coming off. But you enjoy that. Like, I enjoy taking this off, and now I feel good because I feel like I'm making it right.
Making it right. That's it. Yes.
I'm making it right, and I'm paying attention
rewarding.
to I'm paying attention to the details. And that's what's charming about aligning a crankshaft, is you're paying attention to the details, and you feel like, I don't know, for some of us, it makes us feel special. It makes us feel happy that you've seen this dark place. Other people are like, I don't give up. They don't want to open up an engine. And I completely understand that, because I have an appliance vehicle. I have lots of vehicles that require my attention, Jaguars and stuff, and English Fords, and
maybe a fire engine or two.
Yeah, vintage everything. But you also have, a Toyota that you just, like, I just have a 4Runner, and I just changed the transmission fluid on it. And there's a drain plug on the pan. You drain it, you take off the pan. There's 5 magnets in the pan that collect debris. You clean them, you clean the pan, you take the filter out, you put the filter in, everything fits. You put the pan back on with a gasket, and you don't have to smear anything on it. You don't have to, you just put the pan back on. Yep. And then you torque it to, whatever it is, 9 foot-pounds on those pan bolts, and it does not leak. So I do the maintenance, but it doesn't require incantation.
Yeah.
You just do it. So it's good to have the appliance.
It is, because, and there are people for whom the idea of getting down to the crankshaft of your engine, to them, it seems like doing your own surgery. Yeah, it doesn't hurt that much, and I got a mirror, so I can always see what I'm doing. Are you nuts?
I'm going to own up to something. So I had a knee surgery years ago. I broke my knee playing soccer. And I asked the doctor if I could have an epidural, and I could watch the surgery on the screen because it's arthroscopic. And he's like, oh, hell yeah.
Yeah.
So I got an epidural, and I got to be conscious during my own knee surgery. And I got a tour of my knee, and he's like, oh, you see that? That's going to be a problem later. See these cracks in your, in your cartilage up the side? But yeah, watching your own surgery.
Cool.
Huh. Must be a pattern. So bore and stroke, I was sort of curious about bore and stroke. So we got under square on this bike for obvious reasons. But we really, we had trended from under square way back in the day, and bores just grew and grew. I think culminating with sort of the Ducati. What was that? 116? Is that right? 116 millimeter bore.
Okay. Yeah. Yep.
The big one. And then now we've dialed back from that for mostly emissions purposes, but we are seeing the parallel twins come back to a more narrow bore. So I feel like, what's that pattern? The pattern was ultimate performance.
Yeah.
And now we're kind of being, dialed back, getting the clean engines back into.
Well, during the between the wars period, 1919 to 1939, as engines were made to rev up more, they no longer had enough valve area, and you couldn't put in larger valves because the cylinder bore was in the way. So they'd make the cylinder bore 2 millimeters greater. And then they could put in a valve that was 2 millimeters larger. And this process was quite gradual, and it took 20 years. And eventually we got to these ridiculous extremes. But it turns out that the length of top piston ring determines the volume of a space associated with the ring. There's volume behind the ring, there's volume above, because combustion gas has to get in there, get behind the ring, and inflate it against the cylinder wall. During compression and the early stages of combustion, mixture is forced into that volume. And there's nothing you can do about it. It's in there. The thing fires. The peak pressure is reached after top dead center. The exhaust valves open. The pressure drops. But on these wonderful Schlieren photographs that MIT has made in a square cylinder engine with a quartz cylinder wall, you can see that crevice gas streaming up out of the crevice all the way through the exhaust stroke. It's streaming into the exhaust straight to Ann Arbor, where the EPA is located. And
Right,
say,
unburned hydrocarbons.
I smell a rat. I
Yep.
mean, unburned hydrocarbons. So that is pushing back towards smaller pistons and longer strokes. And the market, meanwhile, is just glad that there are motorcycles with only 2 cylinders that they can actually afford. So that, and they make good power. And
They run great. Yeah.
They have a ton of compression. If you're not at 13.4, you're just missing the party. And of course, all these engines, CB750, back in those days, those air-cooled engines were all around 8.5 or 9-1. And they put pretty good sized valves into CB750. What were they? 28 and no, 30 and 28 or something. 32 and 28. Yes, that's right. And then CB350 was bigger yet because it had a much larger bore and a shorter stroke. So these, in the beginning, we're pushed towards larger bore and shorter stroke by the need for more valve area in order to make more power. And at first that was only for racing, but when British Twins reached the US market, there was a commercial horsepower race, which meant either you had to rev the thing up, or you had to jack up the compression, or you had to increase the displacement, something to satisfy, to slake the horsepower thirst of Americans.
Yeah, the origin of the Commando.
Yeah.
And more displacement, great chamber. Pretty good compression,
fast combustion.
Good fast combustion. And then it shook so much they had to find a way to quell that, and they did it with ice elastics.
Yep.
The Japanese came in with a 4-cylinder and obliterated all of that.
Yeah, they made an end run around that. They did something conceptually different. So CB750, I think of it as the gatekeeper that opened a new pathway to performance, which was 4 cylinders, rising RPM. See, a Triumph Bonneville in the mid-60s was peaking at 6,500 RPM, whereas CB750 is peaking at 8,500 or 9,000. And the thing about RPM is it makes more power because it performs the power producing cycle more times per minute. So therein lay part of the secret of CB750, that with moderate compression, moderate size valves, not pushing it anywhere except to turn the RPM that would be easy for an engine with that stroke, they made 67 horsepower to the Triumph Trident's 58. And CB750 was no lightweight. With all fluids, it was around 500 pounds. But it had the rocket engines to push it along the
Yeah.
road.
Yep. And
And
it had torque as well. That was the thing. Because of the
yeah,
moderate tuning, it was really tractable, and it just continued to pull, especially compared to a twin.
it had a kind of a haystack torque curve that had a definite peak, but it didn't slope down very rapidly on either side. So you had 80% of peak torque from 2750 up to just short of 9,000. So you could get some work done within a range like that. The 5-speed gearbox was a classic in that it had quite a low first ratio to get all that weight, possibly with a passenger, and the rider might be a portly person as well, to heave that all into motion. And then the top 4 ratios were like a close ratio gearbox. So it was a new way to reach higher performance. The Japanese had developed production equipment that had low per unit cost. So we could all have one for $14.95.
Yeah.
Just delightful. I wish I'd had $14.95 then, but I didn't.
So, yeah, you mentioned Bob Hansen, National Service Training Manager for Honda at the time, pushing for the bike, and here comes the bike. And Hansen was into racing.
Yeah.
And we got Daytona 1970 CR750. Tell us about that.
Well, Hansen realized that this was a Daytona 200 winner, and when you win the Daytona 200 in those days, people went promptly to the dealership. Well, I've been trying to make up my mind, and you've made it up for me. Here I am, and here's the money. It wasn't difficult to make the 90 horsepower at 9,700 that were claimed for this engine, the CR engine. Bunch more valve timing, greater lift, probably oversized valves a little bit. And they had a winner in potential. So Bob Hansen, his title has the word service in it, and that may have been crucial, because when Dick Mann had completed preliminary practice and they made the first oil drain, there were black bits in the oil. And probably Bob Hansen had seen them before. He knew that they were from the cam chain tensioner rollers, of which there were more than one. And so the engine was torn down, and any oil passage that existed was blown out and cleared with a wire to make sure that the classic failure didn't occur. So many aircraft engines have been changed, but nobody changed the oil cooler, which was full of crap. So they cleaned it out, put it together, fresh oil. We're not running this anymore. So in the race, one of the bikes, there were 4 bikes that were sent over with magnesium cases and 4130 aircraft tubing instead of the mild steel production material. And they burned one of them up in practice. And of the other 2, one of them went 4 laps and the other one went 12 laps. And Dick Mann's bike kept running, and it kept running. And he got in the lead. Oh, it looks like Gene Romero is catching him. Well, will he catch him? Well, that's racing, isn't it? We're excited because we don't know what the outcome is going to be. And in the end, Mann won it. And immediately the cam chain tensioning system failed, and it was a good thing it hadn't happened 5 minutes earlier. And I was party to something that might shed some light on this, or it might not. I just don't know. But in 2020, I got sent to Japan to look at the new Fireblade 1000cc engine. And the engineer told me in early development, we ran the cam chain, and this is silent chain by this time. We wrapped it around the crankshaft sprocket, and then it went to the double size camshaft gears. And he said, we broke chains, we broke side plates. We couldn't stop it from breaking them. We tried all kinds of things with the tensioners, the chain dampers. And finally, someone said, let's put a gear on the crankshaft and a half-time gear directly above it with the cam sprocket, with a chain sprocket. So they slowed the chain down. They didn't wrap it tight around the crankshaft as the prototype had been, and they had a reliable setup. So my thought is, what if the tight wrap of the chain and the problem with the tensioners did not appear at stock RPM and highway and city duty cycle, which is not buzzing around Daytona. So it could be that at 9,700 peak RPM, that the chain was vibrating unbelievably, because when the chain wraps around a small sprocket, and it's about 17 teeth, it is like you're riding on a wheel with 17 sides. It's not comfortable, because as the chain runs onto the sprocket, you see that the pins of the chain form a polygon, not a circle, a polygon with 17 sides. And the chain running onto that is rising and falling ever so slightly. And what if that rate of rise and that frequency of rise and fall corresponded with some quality of the tensioner rollers? Anyway, it generated black bits. The black bits went into the oil pump screen, and no more oil or something. So ever since I made that 2020 trip, I've had this in the back of my mind. What if that was the problem? So interesting stuff.
Interesting stuff. Well, that's the Honda CB750, folks. Thanks for listening. Podcast brought to you by Octane Lending. Click the link in our description. Go check it out. It's called Prequal Flex. If you're shopping for a bike, it makes a difference for us. Just click the link and see what kind of rates you can get. Same as cash going to a dealer. You can be pre-qualified and buy the bike of your dreams. Maybe not for $12 or $15.95, but there are a lot of good bikes in the market today. Thanks for listening, folks. We'll catch you next time.